Hello, welcome to virtual GED class, and we have finally reached the very last lesson that we're going to be doing on basically on graphing and graphing lines and this Cartesian coordinate plane. And we've been doing this for a few months, but the last three lessons have all been on writing equations of lines. So we looked at writing equations of lines when they gave us the slope and the y-intercept, either in words or on a graph. That was the first week. And then we looked at writing the equations of lines when the information we had been given was 2 points. 2 points. That was the next week. And then last class, we looked at writing the equations of parallel lines. And today we're finally going to finish up this subject, wrap it all up with this final lesson here, writing equations of perpendicular lines. And some of y'all know, if you've been with me before, that spelling is not my favorite thing. And perhaps perpendicular has been the biggest spelling challenge of my career. So, okay, equations of perpendicular lines. Obviously, once again, we can't get around it. We have to know what this word perpendicular means before we can continue. So, two lines are perpendicular if they intersect. So they should cross each other. That's what intersect means. Oppose that to our parallel lines that we looked at last class. Parallel lines never intersect. Nowhere on the plane do they ever intersect. But perpendicular lines do intersect. I actually got pissy the other day because I was on Pinterest and I saw some teacher's meme, probably an elementary school teacher, who had said that perpendicular lines are not intersecting lines. And I was like, you're out of your mind. Perpendicular lines are a type of intersecting lines, but that's not the only requirement. They're not just intersecting, it's more than that. They don't just cross. They intersect in a very special way. They intersect at right angles meaning their intersection forms 90-degree angles. Now, some of you guys are like, right angles, 90-degree angles, what are you talking about? If you have not heard this language before, I hope you have, because this is a more elementary school kind of concept, this idea of right angles or 90-degree angles. But if you haven't, we could talk about what that means. Right angles or 90-degree angles are what you want your house to have. For example, the ceiling and the floor. If you have a good carpenter, your ceiling, your walls, and your floor, not your ceiling and your floor, sorry, your walls and your floor will form a perfect, nice, right 90-degree angle. As opposed to if you have a poor carpenter, it looks like me when I build furniture from the IKEA, and your furniture, if your walls and your floor went like that, your house was leaning, you'd probably take up a lawsuit with the carpenter. But anyway, those nice right 90-degree angles we're used to. We see them in squares, we see them in rectangles, we see them in our houses. They're very, very common. Okay, so that's the idea of perpendicular lines. They intersect at these 90-degree angles. So looking down here, oh, and this is the mark that mathematicians will use to say it's a 90-degree angle. They'll put that little square right in there to tell you that's the shortcut way for us to tell you that this is for sure, we promise, a 90-degree or right angle. Okay, so if you look at these two lines here, they are definitely perpendicular. I didn't mark it on this one. Frequently on the GED, they'd be marked to give you that guarantee of them being perpendicular because, you know, we don't, things could look perpendicular and not be perfectly perpendicular, you know. But anyway, I promise you these two are. So let's take a look here. It says, do you remember? We're going to find the equation of each of the lines pictured in the graph. So I see a graph, and remember that we can see two things easily on a graph. We can see the y-intercept, and we can see the slope off of a graph. Because of that, I'm going to put my equations of lines directly into the slope-intercept form, since I can see those two pieces, the slope, the m, and the y-intercept, the b, then it would behoove me to use that form. So I'll start with that. So I'm going to look at the red line first. Red line has a y-intercept. of 4. Our line crosses the y-axis at y equals 4. That means a y-intercept of 4. So we write b equals 4. B is the letter that we use for y-intercept. Okay, so that guy has a b of 4, and look at his slope. So let's see, we can start from any point on the line and go to any other point on the line. So I will do that. Remember, slope is measured by doing rise over run. So this line rose 4. And remember, I like to go from a left point to a right point, so I have less sign errors. And I ran 6. 4 over 6, rise over run. So our slope is a rise over run of 4 over 6. I'm going to reduce that fraction. Both 4 and 6 are divisible by 2. I'll divide that 2 out of both of them. 2/3. If you're mad at me because you don't know how to reduce fractions, your TI 30XS will do it for you. You simply type the N over D fraction button, 4 on top, 6 on the bottom, and press enter, and it will reduce to 2/3. Okay. So I found the 2 pieces of information I need for the red line. It has a slope of 2/3. So I plug in 2/3 for the M. Can you read that 2/3, or does it look like 3/3? Messy handwriting, Kate. And it has a y-intercept of positive 4, so I write plus 4. And that is the equation of that line. Now let's compare that to this perpendicular line, the blue line. So I'm going to go ahead and erase these notes here so we can examine the blue line on the same graph. Okay, so now our blue line. Where does our blue line intersect? Well, clearly intersect the y-axis. That's clearly at -2, so I have a y-intercept, or b, of -2. So I'm going to make sure that I go from a beautiful corner to a beautiful corner. Okay, so now let's go down 1, 2, 3, down 3, and over 1, 2, over 2. So I can see that this time I have a rise of not +3, but -3, because my line's actually going down, and a run of 2, because I went 2 to the right. So that's -3 over 2 slope. So the equation of the blue line is equal to -3 over 2x minus 2. Okay, now I want you, just like before when we talked about parallel lines, you know, parallel lines had a relationship of their slope. I hope you remember that the slope of parallel lines were always equal. They slope at the same rate. But let's take a look at these perpendicular lines. Obviously, their slopes are not equal, but their slopes are related. So like, look at the slope of the red line. The slope of the red line was 2/3. Let's compare that to the slope of the blue line. The slope of the blue line was -3/2. Interesting. We see some similarities. We see some differences. Good. Let's look at one more before we reach any conclusions here. So I'm going to clear this work out here. And I want to look at one more example. You might be wondering what this little T symbol is. It's Kate being too lazy to spell the word perpendicular. Good news is it's not on the GED, so you don't have to have that memorized. But this means perpendicular. Perpendicular slope. We had a 2/3, and then we had another perpendicular slope of -3/2. Okay, cool. One more example I want you to see if we can establish a pattern. So again, I have 2 perpendicular lines. Again, I've been asked to find the equation of each of the lines pictured on the graph. So let's go ahead and look at the red line. Red line crosses my y-axis at 2, so it has a b of 2. And then it seems like we are going, so I will not make the mistake I made last time, and I will definitely go from a corner to a corner. There we go, that's a corner to a corner. So I'm going to go down 2, 4, 6. I went down 6, -6, and I go over 1, 2. And so I have a slope of -6 over 2. Now, obviously, that guy will reduce. -6 divides perfectly by 2. That's -3. So I have a slope of -3 for my red line. So my red line equation would be y is equal to m is -3, and I have a positive 2b, so I write plus 2. Now let's look at this blue line. This blue line has a b of 0. It's crossing the y-axis at 0, but its slope, let's see. Again, I will not screw up the way I did last time. I will go from a point, a corner point, I mean, to a corner point. There we go. So let's see, we went up 1, 2, up 2, and I ran 2, 4, 6 over 6. So this guy has a slope of positive 2 over 6. Now 2 and 6 are both divisible by 2, so this thing will reduce. It reduces to 1/3. Again, you can reduce in your TI-30XS if you would rather. You just use the N over D button for a fraction bar, and then you can arrow around there to type in the fraction 2/6 and press enter, and you will see it reduces to 1/3. Okay, so this guy has a slope of 1/3. So I write y equals 1/3 x, and it has a y-intercept of 0. So I could write plus 0, but as we keep discussing, mathematicians do always use simplified answers. So I know adding 0 does nothing, and so I just write y equals 1/3 x. Now, once again, I want us to compare the slopes of these two perpendicular lines. When I had one line with a slope of -3, the line that was perpendicular to that had a slope of 1/3. Okay, so the question really is, what did you notice? Did you notice anything about these perpendicular lines? How are the slopes of the perpendicular lines similar? Well, one thing I do notice is, one thing that's similar is the numbers. This one, for example, had a 2, and the perpendicular line also had a 2. This one had a 3, and the perpendicular line also had a 3. But notice that the relationship between 2 and 3 is flipped. The fraction has been flipped on its head. 2/3 turns into 3/2. And so what do I notice? How are the slopes of perpendicular lines similar? The numbers are similar. But I also want to ask you, how are they different? We see here that we have a reciprocal. They're flipped upside down on their head. Now maybe you're saying, Kate, does that really apply? Look at the next example. Is the next example like that? Are the numbers really the same? Well, I see 3 and I see 3. Now you might be saying to me, Kate, I see a 1 over here on this number, but I see no 1 over here on the other number. But please, 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 please remember that all whole numbers, and we've been talking about this since the beginning of slope, all whole numbers, well, this is really an integer, but it doesn't have a piece or a part. It's not a fraction or a decimal. Anytime something is not a fraction, you could dress it up to look like a fraction by throwing it over the number 1. -3 one whole things is the same as just -3. Remember, the denominator of a fraction just tells you the size of the pieces. So it's, you know, we don't brag about having one whole thing because we always have one whole thing with whole numbers or integers. But in this case, we can see that even though you didn't see it, there really is a 1 on the bottom here. And so we definitely see this reciprocal property again. We see that the numbers are flipped. The number that was on top comes to the bottom, and the number that was on the bottom comes to the top. I notice one other thing that's different about the two slopes. Did you see it? Take a look at the signs up here. Take a look at the signs up there. On the top, this first slope was positive. And then on the bottom one, this second guy's slope was negative. Does the same hold true of the other one? Indeed, our first line this time, our red, was negative, and then our second example was a positive. And so we can see that perpendicular lines are similar in that they have the same numbers, but they're different in two ways. First of all, they're reciprocals. They're flips of each other. The numerator comes to the denominator and the denominator comes to the numerator, the fraction. They're flipped upside down. They're reciprocals. That's what that math word means. And the second thing is that they are opposites. And when I say opposites, I mean they have opposite signs. There's actually two ways to think about opposites in math. There really are. There's two ways to think about opposites. And I won't make you memorize this language again, but there are math terms for this. It's known as the additive inverse. So the opposite when you're adding is the opposite sign. So that's what I'm talking about there. But there's also something known as the multiplicative inverse, the opposite when you're multiplying, and that's the reciprocal. So it's really interesting because when you look at perpendicular lines, they're opposites in both ways that you can be opposite. I say that again, they're opposite in two ways, both ways that a number can be opposite. They're reciprocals and they have the opposite sign. So let's write that rule that we just discovered down because that's what's going to be super important to us. What's the rule? The rule is that perpendicular lines have slopes. Remember, it was the slopes we were comparing that are opposite in two ways. Okay, the first way that they're opposite, as we stated before, is that they're reciprocals, they're flips. The numerator becomes the denominator becomes the reciprocal, but that's not enough. It's not just that. It's not just reciprocal. Second rule, they have opposite signs. So if one's positive, the other will be negative. If the first one's negative, the second one will be positive. So two things we got to check to determine if two lines are perpendicular. Okay, so let's go ahead and apply this concept. So first of all, I got a little vocabulary check for you guys. This problem here says, are the two lines shown in each picture parallel, perpendicular, or neither? Well, hopefully when you look at this, okay, looking at example A, we're asking ourselves, are they parallel? Well, remember that parallel lines run in the same direction for forever and never cross. Obviously, A is not perpendicular because not parallel because these two lines cross. Okay, and so we can rule out that. We could determine, are they perpendicular? Well, two lines are perpendicular if they cross at those perfect right 90-degree angles. Look at this angle. That's wide open angle, way bigger than you would want in the corners of your house. That is what we call an obtuse angle. It is not perpendicular. It's more than 90. And then even here, if you looked here, that's an acute angle. It's really tiny. It's smaller than 90 degrees. There's no way that these guys cross at perfect right angles. It's not perpendicular either. And so I would say that A is neither. Even though these are intersecting lines, they are not perpendicular. And so that's neither. Okay, now let us examine the pair of lines in B. Again, we're asking, are they parallel, perpendicular, or neither? Well, I suspect parallel because they're not crossing at all. But remember that if they're parallel, they're never going to cross. So make sure that they are like equidistant apart, equal distant apart forever and ever, amen. And they're never going to cross. Imagine those lines going off forever in either direction. Imagine them on an unending plane, and you can see that indeed these guys are parallel. They are at that exact same slope, so they're never going to run into each other. And so these two lines are parallel. Okay, now let's look at pair C. Again, we're just doing a little vocab check. Are they parallel, perpendicular, or neither? Well, you could see pair C, they are intersecting. Okay, so there's a possibility that they're perpendicular, but are they intersecting at a perfect right angle? Not only do they appear to be at a perfect right angle, it looks like they are. I mean, those look like nice corners there. You might be saying, but Kate, they're slanted. It doesn't matter if they're slanted. It matters if they're at that perfect angle. I mean, you can pick up your bookshelf and like move it this way, this way, this way, but hopefully you still have those nice right angles on a bookshelf. So definitely I have the appearance of 90-degree angles, but I also have proof. See that little square marking the corner? That is mathematical proof. That's how mathematicians mark a 90-degree angle. So these are definitely perpendicular lines. Okay, so now that we know the vocabulary we're going to need in order to work on these GED problems, let's go look at some other types of examples. Okay. So concept check says determine whether each pair of lines is parallel, perpendicular, or neither. So we said lines were parallel if they ran in the same direction forever and ever without running into each other. But how did we tell that in an equation? We know how to tell that in a graph. How do we tell that on an equation? Remember, in an equation, if they're parallel, they have the same slope. Okay. Again, another choice is that they can be perpendicular. So, okay, either they could have the same slope if they're parallel. Remember, if they were perpendicular, they were opposites in two ways. Two ways. They had the opposite sign and they were reciprocal. Not just one of those two ways, both of those have to be true. So reciprocal and opposite signs. And then, of course, anything else would fall into the neither column. Okay, so you can see that on all of these, we're going to be comparing slope. If it's parallel lines, they would have the same slope. If it's perpendicular lines, their slopes are reciprocals with opposite signs. So give yourself a little note here. If you're determining if lines are parallel, perpendicular, or neither, what you're comparing is their slopes. And gee whiz, one more problem on the GED that's a slope problem. Like we need it anymore. I've been telling you forever, it's one of the GED's favorite topics. So again, remember, if you take a look at these lines, look at all of them, they all appear to be in that y equals mx plus b format. So cheer whenever lines are like this, whenever that y is alone, because it means you can very easily see the slope. The slope is the m, the number shoved up against x. Okay, so let's compare our slopes. On our first line, our slope is 2, because there's a 2 shoved up against that x. On our second line, the slope is -2, because there's a -2 shoved up against that x. So remember, if the slopes are identical, these lines are parallel. Well, the two lines do not have identical slopes. If the slopes are perpendicular, they'll be opposite in two ways. They'll be reciprocals and opposite signs. Now, I do notice that these two lines have opposite signs. This one's a +2, and this one's a -2, so that's promising. However, they aren't reciprocals. Remember that if any number is by itself, it doesn't look like a fraction, you can dress it up like a fraction by putting it over 1, 2 one whole things. And so if I were to flip this thing on its head, I wouldn't get 2, I would get 1/2. And so these two things are not reciprocals, and so these two are neither. Okay, let's take a look at another example. So again, I just need to pull out and look at my slope. This guy is in y equals mx plus b formula, so I can do that. My slope on my first line is 2/3. My slope on my second line is -3/2. Okay, are these guys parallel? Nope, the slopes aren't identical. Are these guys perpendicular? They look suspiciously so. Let's check the two checks. Remember, perpendicular lines have two things in common in their slope. One, they should be opposite signs. And indeed, this guy is positive and this guy is negative. So check opposite signs. But the second thing is they need to be reciprocals of each other, flips. Let's take a look. This guy has a 2 up top and a 3 on the bottom. This guy has a 3 up top and a 2 on the bottom. Indeed, it is like you just flipped this fraction on its head. They are reciprocals. And so this guy passed both of the checks for perpendicular lines. These two lines are perpendicular. Let's go look at the next one. Again, I'm trying to determine whether these two lines are parallel, perpendicular, or neither. And so I will compare their slopes to do so. The slope of the first line, see that number shoved up against x, is 2/5. The slope of the second line is also 2/5. There's a 2/5 shoved up against that m. See how these two slopes are identical? These two lines are parallel. Okay. Next one I put in on purpose just to see if I could trick you guys. This is one that tricks a lot of students. Most students tell me that these guys are neither parallel nor perpendicular. They give me the answer of neither. But I'm just curious, did you actually consider what is the slope here? Don't just look and compare any numbers here. Remember that when you're asking yourself if it's parallel or perpendicular, you're comparing slope. And let's look at the first line, y equals 3. Is that 3 shoved up against an x? No. So that 3 is not a slope. Slope is always multiplying with x because it's the rate of change. As it multiplies with x, it's going to force my graph to change quickly or slowly. It's the rate of change. And so I don't see any X's in this. I mean, look at this. Do you see an X in there? No, there's no X's, guys. There's none. We have a number that means no X's and it's 0. So this guy has a slope of 0. Examine the next line. What number is multiplying with X? How many X's are there? You know, how many X's are there? Well, there's no X's here either, are there? Watch out, that's a trick question. Those guys might not have the same y-intercept, but we don't care about y-intercept. We care about slope. They both have no X's. They both have a slope of 0. These two lines are parallel. That will trick all but the savviest of students. So you've been warned now. The GED does love a trick. So make sure you're aware of that kind of problem. Okay, next one. So again, if I want to find out if lines are parallel, perpendicular, or neither, I should compare their slope. So let's look at the slope of the first number. Do you see something multiplying with X? This time I do. I have a 3/4 X. And let's look at the slope of the second number. 4/3. And I have a ton of students who go, Kate, look, they're reciprocals. They're reciprocals. These two lines must be perpendicular. But remember that there's 2 qualifications for perpendicular. Not only are they reciprocals, flips of each other, they also have opposite signs. Do you see how these 2 lines have the same sign? They don't pass the perpendicular check. Both things have to be true. And so they're not parallel because they're not identical. They're not perpendicular because they don't pass both rules. These 2 lines are neither. Neither. Okay. Another tricky little problem I wanted to do with you. Okay. Let's take a look. So again, we've been asked to determine whether the lines are parallel, perpendicular, or neither, which means we're going to compare their slope. I want to talk about the slope of the first line. Students tell me all the time that the slope of the first line or the second line, either one, is 0. They're like, Kate, there is nothing in front of X, so that's 0. And I'm like, not true. If there were 0 X's, X would have disappeared completely. No X's, X is gone. That's not what's going on here. I do have an X. How many X's do I have? Well, if I don't bother to count, you're guaranteed that there's just 1 X. If I don't bother to count, so if there's no coefficient, no number up front, that is a 1. So even though you might think at first it's 0, that is a negative 1x. Okay, it's like I owe you a single solitary x. I don't have to say 1x, I can just say an x. Okay, so same thing on the second line. If you look at the second line, I have a slope of what? Well, there's no number shoved against x again, so that must be the invisible coefficient of 1. I have 1x there too. And so that was one way this problem is tricky. But man, this problem is super tricky because now students tell me, Kate, look. These two have opposite signs, so they pass one of the checks for perpendicular. However, they're not reciprocals. They're not flips of each other. And I'm like, oh, they're not? Let's check. Okay, so this first number, again, it doesn't look like a fraction. Let's dress them up like a fraction by throwing them over 1. Remember, you're always allowed to throw a number over 1. It's -1, one whole thing. Okay, so now if I were to flip 1 over 1, what would I get? 1 on top and 1 on the bottom. It's the same number. And so this one would end up 1 over 1. So are they reciprocals? Do they have opposite signs? They passed both tests for perpendicular. These two lines are perpendicular. Tricky. By the way, 1 is the only one that behaves that way because 1 is the number on the bottom of a fraction that you basically can't see. When you don't see the bottom of a fraction or the denominator, its denominator is 1. Okay, tricky. Okay, so this could come up on the GED, but this is a more simple example of these kind of problems. So let's get it a little more complex, how you're more likely to see it on the GED, where you're actually writing the equations yourself. I have some examples here. Okay, let's take a look. Example 1 says, find the equation of the line that is perpendicular to the line y equals 2x minus 1 and runs through the point 0, -5. So we've been told to find the equation of the line. As I hope you remember from last class, we have 2 equation of line formulas on the GED formula sheet. You have the slope intercept form, and we have the point slope form. Most students prefer the first one if they can get away with it. So I try to opt for the first one. If I have the slope and the y-intercept, I go straight to the first formula. If I have a slope and any other point, I'll use the second one. So let's see what we have. We've been told to find the equation of our line, but we have some different information. The first thing we know that our line is perpendicular to this line. Now you might say, Kate, that has nothing to do with anything. What does that have to do with? Remember, when lines are perpendicular, we know something about their slope. We know something, we just learned that. When lines are perpendicular, they have related slopes, not the same slope, that was parallel, but related slopes. So you can see the slope of this line is 2. I have a 2 shoved up against my x. So if my line is perpendicular to this line, I know that my line has a slope that's opposite in 2 ways. So a perpendicular slope will be opposite in 2 ways. It will have the opposite sign. Well, this is a positive 2, so my perpendicular line will have a negative slope. But that's not the only way it's going to be opposite. Remember that it'll also be the reciprocal. Now, 2 doesn't look like a fraction, so we will dress it up like a fraction by putting it over 1. And now it's easy to take the reciprocal. Flip 2 over 1 upside down on its head, and you get 1/2. So even though they didn't directly state the slope, we know the slope because of this concept of perpendicular. Next piece of information we have. We see that our line runs through the point 0, -5. Now I'll say to you, what is this thing? And you might say, Kate, that's a point. And I would absolutely agree with you. That is a point, but it's a super special point. We've been talking about this the last 2 or 3 classes. Remember that when a point has 0 as its x-coordinate, it is a y-intercept. So this is a point, but it's also a very special point known as the y-intercept. So I can see the y-intercept here is -5. Because I know both the m and the b, I will use the slope-intercept equation of a line, and I will plug into that. So y is equal to -1/2 x, and since it's -5, I will write -5. And that is the equation of my line. Awesome, let's try a few more. Again, find the equation of the line. Again, I'm going to reserve judgment on how I do this depending on what I've been given. Let's look at what we've been given. Well, we know our line is perpendicular to that line. Well, we know that when lines are perpendicular, it tells us something about our slope. So if that line's slope is -4/3, our perpendicular slope is going to be the opposite sign, so it'll be positive, and a reciprocal, so it'll be flipped on its head. Our line will have a 3/4 slope. And it runs through the point 0, 0. Once again, I see a 0 in the x-coordinate. So I know this thing is a y-intercept. So my y-intercept, my b, is 0. Okay, wonderful. So I can see my m and my b, so I'll plug into the y equals mx plus b slope-intercept equation of a line. So y equals 3/4 x. Now, can I write +0? Yes, but as we've discussed a lot already, you shouldn't, because you're a mathematician and you know that adding 0 does jack. So the equation of this line is just y equals 3/4 x. Let's do another one here. Find the equation of the line that is perpendicular to that line and runs through the point 2, 5. Okay, so I've been told to find the equation of the line, and once again, I can see my slope. Since this line has a slope of -3, my perpendicular line will have a slope that's opposite sign, so positive, and reciprocal. So if it doesn't look like a fraction, throw it over 1 so you can flip it upside down on its head. My guy will have a slope of 1/3. Now, the second thing I've been given this time, is this point a y-intercept? No, it is not. Notice there's no 0 in the x for the x-coordinate. And so this guy is just any old point, not the very special point of the y-intercept. And so I have a point and I have a slope. There are multiple ways to go here. There's more than one way to do this. But since I have a point and a slope, I am going to choose to use the point slope formula. So I bust out the point slope formula, y minus y1 equals m times the quantity, x minus x1. And if you think I'm doing this pretty fast, it's because you haven't watched the last two videos, okay? We got up to speed on these concepts. So go back and watch the last two classes if this is too fast for you. But remember that there's three things I need to plug into the point slope formula. The slope, the m, and the point, that's x1, y1, are the x and y coordinates of the point. So let's plug in y minus y1 is my y coordinate of my point, that's a 5, equals my m is 1/3 times the quantity of x minus my x coordinate of my point is 2. Okay? Now, again, something we did over and over last class is we said that even though you can use point slope form of the equation of a line at the beginning, you want to do the simplifying and solving that it takes to turn this guy into slope-intercept form. You want your final answer in slope-intercept form. So first I will do the simplifying that's implied on the right-hand side. That 1/3 is shoved up against that parentheses, so that 1/3 is multiplying. So let's do that. I'm not going to change my left-hand side because there's no work to do on the left-hand side, but I will multiply 1/3 times x. You do that by just shoving them together. And I will multiply 1/3 times -2. Now, guys, could I use my TI? Yes, and I'll show you how in just a second, but could we just real quickly talk about common sense for a second? I want you to imagine that I have 1/3 of something. There's 1/3. Okay. Now I want to multiply that by 2. What does it mean to multiply that by 2? It means to have that exact same thing 2 times. 2 times. So I'm going to draw this exact same picture a second time. Guys, if I have 1/3 2 times, what do I have? 2/3. Can you see that picture? I have 2/3 shaded in right there. Of course it's 2/3. Okay, now maybe you don't believe me, so we can do it in the TI calculator. So I can do 1/3 by using that fraction bar, n over d, and arrowing around. I'll make sure I'm out of my fraction before opening up a parentheses and typing -2. Remember, a -2 is like a -2. And I press enter, and of course I do get -2/3. Common sense matches my calculator work. Okay, great. So this guy's almost done, except for it's not in slope-intercept form yet because y is not alone. In order to get y alone, I'm going to have to get rid of this -5 by adding 5 to both sides. So on the left-hand side, subtracting 5 and adding 5 cancels, so that y is alone. On the right-hand side, I didn't do anything to 1/3 x. Now, this is where you really might want your TI-30XS calculator because it is easy to multiply and divide fractions, super simple. But it's much more challenging to add and subtract fractions. And look at this work I have to do. -2/3 plus 5. I've got fractions going on, whole numbers going on, negative signs going on. You might really appreciate your calculator for this. So I'm going to do this in my TI. Now, I didn't mention this before in this video, but anytime you're working in fractions, it's a really good idea to make sure you're in math print mode. The fractions look more normal. You'll make less typing mistakes. Math print is designed to handle things like fractions very well. So in order to do that, press your mode button. Arrow down using the down arrows and the right arrows until you're blinking over the word math print and press enter. That will select it. Now to get out of that mode screen, you'll need to press clear. Great. Now I'm in math print mode so I can be sure that my calculator will look nice as I try to do these fractions. So first I will type in -2/3. So negative, and over D button, 2 on the top, arrow down to the bottom, thirds. Now make sure you get out of your fraction by pressing the right button before you press +5, +5. And I see that I get this fraction 13/3. And you might be thinking, oh my gosh, that's an improper fraction. My 3rd grade teacher told me I could never use improper fractions. They're the devil. 13's too big. And I just have to tell you that in algebra class, we have no problem with improper fractions whatsoever. So it's a positive 13 thirds, so I'm just going to write 13 thirds. I'm totally okay with 13 thirds. So is every algebra teacher I've ever met. I don't know why they make you so scared in elementary school of improper fractions, but they're totally legal. Okay, there's nothing wrong with them. They're just another form of a number. Okay, so there you go. That's the correct answer there, and my calculator did the hard work. Okay, last one on this page. Let's take a look. Find the equation of the line that is perpendicular to y equals 5/2 x. Can you guys see that? To y equals 5/2 x minus 4 and contains the point -4, 3. So once again, we know that if our line is perpendicular, that its slope is going to be the opposite sign. So this has a positive slope, so ours will be negative, and it's going to be a reciprocal, so it'll be -2/5. And I can see that the other piece of information I've given is the point. Well, if I'm finding the equation of the line when given slope and a point, I should bust out the point slope form. Y minus y1 equals m times the quantity, x minus x1. And again, I kind of like feel like I'm beating a dead horse because I said this so much in the last video, but you don't have to have this memorized. Okay, it's on the GED formula sheet. Now we'll plug in what we know. We need to plug in the slope and the x and y coordinates of the point. So y minus the y coordinate of my point is 3 equals m. So my slope is -2/5 times x minus my x coordinate, which is a -4. Now notice I have a minus in my formula, minus, so I have that minus, and I also have a minus in my number, -4. So my equation ends up with 2 negatives. Now you might be saying, Kate, what in the world? How am I going to deal with 2 negatives in a row? How can I minus something? Now is when you deal with that. 2 negatives in a row can be read as the opposite of -4. Well, the opposite of negative is positive, or the opposite of subtraction, another way to think of it, is addition. And so minus turns into plus. Okay, now I will do that distribution. And again, I'll probably use my TI to help me. So on the left-hand side, I've made no changes, so I'll still have y minus 3. And on the right-hand side, -2/5 times x is -2/5 x. And -2/5 times +4. I'll do it in my TI. -2 n over d5 times, I'll use parentheses, times 4, close parentheses, equals -8/5. Okay. Almost done, almost done. I just got to get my y alone. So I'll add 3 to both sides to get rid of that -3. I did not give myself enough space on this problem. Okay, so on the left-hand side, subtracting 3 and adding 3 will cancel, so my y will be alone. And on the right-hand side, I didn't do anything to -2/5 x, so it'll remain. And I'll do this work in my calculator. -8 over, n over d. 5 come out of my fraction, plus 3 equals +7/5. So I'll write +7/5. Final answer. I don't care if it's messy. Your calculator took care of the messy. Okay, now that being said, if you know how to do fractions, it's probably faster than using a calculator, but too many students waste too much of their life spending like years and years and years trying to learn fractions. Okay, we can learn higher math even if we can't do fractions. So done with this page, let's look at some more examples. Example 5 says find the equation of the line that is perpendicular to all this jazz. So remember, if lines are perpendicular, then we know that its slope is opposite in 2 ways, opposite sign. So this one had a negative sign. We will have a positive slope, and it's opposite in its reciprocal. It's a reciprocal. So this one is a fraction 3/4, so ours will be 4/3. So our line will have a slope of 4/3. Now, we can also see that we know a point on this line, the point 12, -2. So since I know a point and a slope, I will use the point slope form. Let's plug in the y value of our point. Whoops, I put an equal sign when I was supposed to put a minus sign, y'all. So y minus Now you can see the y value of my point is -2, so I'm going to end up with that extra negative, equals m. So this guy had a slope of -3/4, so my perpendicular slope will be +4/3 times the quantity of x minus x1, my x value of my point, which is 12. Great. So on this side, this time we do have some simplifying on the left-hand side. Minus minus turns into plus, so this guy turns into y plus 2. And on this side, I can do my distribution, pass out my multiplication. 4/3 times x is 4/3 x. And I love 4/3 times -12, even if you do it in your TI. So let's see, 4/3, arrow out of your fraction, times -12. You're going to see that it gives you a nice whole number, -16. Okay, now I'm almost done, but my y is not alone, so I'll subtract 2 from both sides to get rid of that adding 2. So y is equal to, I didn't make any changes to 4/3 x, so it'll still be 4/3 x, and -16 minus 2 is -18. Wonderful. Okay, so that's your final answer there. Y is equal to 4/3 x minus 18. They don't always come up with ugly, nasty fractions, but even when they do, your calculator can handle. Okay. Okay, so example 6 says, what is the equation of the line? So again, I've been asked to find the equation of a line that passes through the origin. I did this to you last time too. You guys have to know that vocabulary word in order to understand this question. What is the origin? The origin is that very special spot where the x-axis and the y-axis cross. It is a point, and it is the point 0, 0. Either you know that or you don't. So we are going through a point, and it's perpendicular to y equals -x plus 5. Now remember, when lines are perpendicular, they have slopes that are opposites in two ways. So you can see that my particular slope up here has a slope of, well, it just looks like -x. So what's the slope? What's the coefficient, the number multiplying with x? Well, of course, as we said before, the invisible coefficient is 1. We never bother to brag when we have 1x. We're just like, there's an x. Clearly, can you count to 1? There it is. Okay, so m is equal to -1. Now, if I want to find the perpendicular slope, remember that I need to change the sign, so mine will be positive, but I also need to flip this guy in its head. So this is currently 1/1. So if I flip it, the denominator of 1 becomes a numerator of 1, the numerator of 1 becomes a denominator of 1, and 1/1 simplifies, of course, to just 1. So this guy has a slope of just 1. Wonderful. So let's go ahead. We know the slope. We know a point, but it's not only a point. Do you see that? It's a super special point. Since that's a 0, this is a y-intercept. And you say, Kate, I would never notice that in a million years. And I say, that's okay. If you didn't notice that that was a y-intercept and you did this the other way with the other equation, you'd get the same exact answer, okay? So don't stress. But I am going to plug directly into mx plus b form because I can see that I have the m, the slope, and I have the b, the y-intercept. And so let's do that. M is equal to 1x plus 0. Now, of course, as we know, adding 0 does nothing, and multiplying by 1 does nothing. So this is just the line y equals x. Great. Now, I'm actually not going to do example 7. I was rushing to make my lesson plan this morning and left one in that I didn't mean to leave in. So we are done for today. Hopefully you've got a handle on this. I highly suggest, now that we've finished all the different ways of writing equations of a line, you do some mixed practice. It is so important that you do mixed practice, and students don't realize it. Y'all will do one thing for a couple days, then another thing for a couple days, then another thing for a couple of days, and you never do the mixed practice. And that means you're never prepared for a test. Because on a test, you don't do the same thing 50 times over and over again. You go back and forth and back and forth, and you have to think, what kind of a problem is this? What should I do? And so some mixed review is going to be super important as you think, well, okay, when I write the equation of the line given this, what will I do? When I write the equation of the line given that, what will I do? That kind of thinking is so important, and it should not be skipped, okay? Okay, great. So we are all done with this series. Yay! And I haven't even decided what the next series is yet. So until next time, happy learning.